The last type of inequality that we're going to look at is a rational inequality, where we are going to have variables in the denominator of a fraction, not just up in the numerator, like with polynomials. Now with polynomials, we found that we really needed to pay attention to when the expression was equal to 0, because that's the time where it can switch from being positive to negative. It's not going to switch any other time. So what I think would be a good idea is to take a look at a rational expression and see if we can get a sense of whether we can follow that same rule or if we need to add to it in terms of looking for when we switch from positive to negative. So to do that, I'm going to ask us to graph this in our graphing calculator. So we're going to graph y equals this rational expression right here. So in the graphing calculator, I've already taken the liberty of typing in the, sorry, let me reposition this here. So I've already taken the liberty of typing in the expression into my y1. Just one thing to take note of real quick is that I put parentheses around the numerator and the denominator so that it's really clear to the graphing calculator, which factors are in which part of the fraction. So if I hit graph, I get this picture here. Now let's think about what the equation was once again, right? So remember, up on top we had x minus 2 and x plus 3. So that means that negative 3 and positive 2 are zeros. And so when I go to the graph once again, we'll notice here negative 3 and positive 2 are zeros, and notice that is a place where we're switching from being positive to negative. Positive to negative. So we're definitely having that switching there. But then there's also this switching at, looks like at x equals 0. We went from negative to positive when we crossed that. And it looks like about 5. We go from negative to positive. So there's something else happening besides zeros that is causing this graph to switch from being negative to positive and vice versa. So if I go back to the equation, 0 and 5 are the things that make the denominator, the bottom of the fraction, 0. So in the case of rational inequalities, what we need to do is not only look out for things that make the fraction 0, but we also need to look out for things that make the denominator 0 as well. So just to summarize, we can switch signs at zeros and at places where, and I'll put it this way, the expression is undefined. And undefined due to dividing by 0. All right, so let's do an actual example here. And here's a list of steps, but we'll come back to this in a moment. So in example 8 here, we want to solve this inequality where we have 3x over 1 minus x is less than or equal to 0. Now, what we can see is that there's a 0 at x equals 0, right? If you let x be 0, the top becomes 0, making the entire expression 0. There is a spot where this expression is undefined at x equals 1. Okay, so let's set up a sign chart like we did with polynomials. So I'll have a 0 and put this here. Now, and I'm putting a solid line, right, because I'm saying less than or equal to. Now, when I put a 1 down, I'm going to go ahead and put a dashed line. And I'm doing that because even though the inequality has an equal sign in it, I don't ever want to allow a division by 0 in an expression, regardless of what the inequality is. So automatically, we're going to put dashed lines anytime we're working with a rational inequality and we're looking at that spot that makes it undefined. So this is our sign chart. And so now we can, plug some things in, 3 times negative 1 over 1 minus negative 1. That's going to give me negative 3 over 2, so that's negative. We'll try, how about a half? 3 times a half over 1 minus a half. So that's 3 halves over 1 half. And all that really matters, I guess that equals 3, but all that really matters is that it's positive there. And then let's do 3 times 2 over 1 minus 2, so that's 6 over negative 1, so that's negative. And of course, we wanted things that were less than or equal to 0, so we're picking these intervals here. So this being a solid line at 0, it's okay for me to plug x equals 0 into that expression. It still lets this be true. So I'm going to say we're going to go from negative infinity up to 0. And we'll put a bracket there and include 0. And then we'll pick things back up again at 1, but we're leaving 1 out, right, so that we don't end up dividing by 0. All right, so just to go back up for a moment to the steps. So there's these first two that we did not have to address in example 8, moving all terms to one side and combining one side into a single fraction. Okay, we're going to see that in some inequalities coming up. Factoring we also didn't have to do in this one, but we do need to factor if it's not already done for us. And then number 4 we did do. When is the numerator and denominator 0? Plug in our test points and then use that to create our intervals. All right, so let's look here at example 9. So example 9 has us look at this. 8x minus 3 over 2x plus 5 is greater than or equal to 1. Now, this looks maybe pretty similar to the last one, but there's a big fundamental difference. Here we had 0 on one side. Here we have 1. So here's where we have to follow step number 1 of that process on the previous page that said, hey, first you got to get everything on one side, right? So I have to begin by saying x minus 3 over 2x plus 5 minus 1 is greater than or equal to 0. And then, also on the previous slide it said, or previous page, it said we need to combine into a single fraction. Well, to do that, I need a common denominator, right? So I'm thinking, okay, this is 1, and I'm going to multiply by 2x plus 5 on top and 2x plus 5 on bottom. And then that allows me to combine these into this single fraction. And then, of course, I want to simplify. So we've got, looks like negative x minus 8 over 2x plus 5 is greater than or equal to 0. So, once again, we got to figure out, this thing is going to be 0. Well, clearly, when negative x minus 8 equals 0, which means negative x equals 8, which means x equals negative 8. So that's my 0. And we are undefined when 2x plus 5 equals 0. So 2x equals negative 5, so x equals negative 5 halves. So in this case, our sign chart is going to be, I'm going to do this in a different color just to make it stand out, negative 8 and negative 5 halves. It's greater than or equal to, so it's okay for this thing to be 0, so I make a solid line here. I do not, however, want to divide by 0. So I'll put a dashed line there. All right. Now we've done this sign chart of plugging things in many, many times, right? So what I want to do here is just kind of cut to the chase. So after plugging in a value to the left here, this should be negative. Plugging in something in here, this should be positive. And then when I'm over here, this should be negative again. So that gives me, what did I want? I wanted this to be greater than or equal to 0. So that means I want from negative 8 bracket up to 5 halves parentheses. All right, so let's look at one more rational inequality. So just like in the last problem, we want to get everything on one side if it's not already. So 1 over x minus 3 plus 1 over x plus 2 minus 2x over x squared plus x minus 2 is greater than 0. On the previous page, we also talked about if anything needs to be factored, we need to factor it, whether it's at the beginning in order to figure out a least common denominator, or later when it's actually time to create our sign chart and everything. So I want to factor this here. So this is 2x over, and let's see what this factors into. So it looks like x plus 1, x minus 2 is what that factors into. Let's see. Oh, it doesn't. Got my signs off. The way I had it would give me a negative x here. I want a positive x. So minus 1 plus 2. That'll do the trick. Okay, but now we need to combine everything. So first of all, we need to understand our LCD here. LCD, what is it? Well, it's the smallest thing that everything can be a factor of. So we definitely need the x minus 1. We definitely need the x plus 2. Here, x plus 2 fits into x minus 1 times x plus 2, but x minus 3 does not, right? So we also need an x minus 3. So that's the LCD we're trying to create in all of these. So I have 1 over x minus 3, and I am going to multiply that by, on top and bottom, x minus 1, x plus 2, x minus 1, x plus 2, then 1 over x plus 2. So this I want to multiply by x minus 1, x minus 3, x minus 1, x minus 3, minus 2x over x minus 1, x plus 2. So the only thing that's missing is the x minus 3. So multiply by x minus 3 on top and bottom. Okay, so now we can combine it all. So I can have x minus 1 times x plus 2 plus x minus 1 times x minus 3 minus 2x times x minus 3 all over x minus 1 times x plus 2 times x minus 3 is greater than 0. And then we have to clean up that top, right? So going back to this previous page here, it says, let's see here, where are we at? Factor the numerator and denominator, right? So we've got a numerator and denominator, and the denominator is factored, but the numerator is not. So we've got to simplify that top in order to be able to factor it. So x squared plus x minus 2 plus x squared minus 4x plus 3, and then minus 2x squared plus 6x, all that over this, x minus 1, x plus 2, x minus 3 is greater than 0. Now I can see that I'm running out of space here, so I apologize if I didn't give you the space you need on your set of notes. But we're going to move this onto a new page so I don't have to write too small. There we go. All right, so what do we have here? Well, one thing that's nice is I have an x squared, and minus 2x squared, and so those all go away. So, so what I'm left with here is I have x minus 4x plus 6x. So that's 3x. And I have minus 2 plus 3, so that's plus 1. And that top now does not need to be factored any further. So what do we have? Well, as far as zeros go, we have 3x plus 1 equals 0. So when x equals negative a third, that's a 0. But then we have undefined at 3 different places, right? At x equals 1, at x equals negative 2, and at x equals 3. So our sign chart then looks like this: negative 2, negative 1/3, let's see, 1, and 3. So I'm putting I'm putting dashed everywhere. You know why? Definitely putting dashed here, here, and here, because that's what makes us divide by 0. But since it's a strict inequality anyway, you'd also put 1 right there. So with all that said, what we're going to do is plug in values. And again, we've done this a number of times, so I'm going to kind of fudge on it a little bit and say, all right, if you were to plug in something to the left of negative 2, like negative 3, for example, you would end up with a positive value there. If you plug in something in here, you're going to end up with a negative value. In here, a positive value. And just maybe let's pause. In between here is 0, right? So you can see if you put a 0 in all these spots, you would end up with 1 on top, negative 1 times 2 times negative 3. Well, the negative 1 and the negative 3 become positive, and so it's a positive divided by a positive, which is positive. So just to, show that, yes, that mental arithmetic we're doing here is working. That would be minus, and that would be plus. So we wanted the plus, right? So our solution here is we want from negative infinity up to negative 2. And we want from, let's see here, negative 1/3 up to 1. And we want from 3 up to infinity. All right. Now, just real quick before we leave this one in the past, this was a hard one. right? And it would be one that would be good to kind of check our work on. So if I go back here for a second, let's just make a note of how we can check this. So we don't want to lose sight that our graphing calculator can help us out. So here's what we're going to do. Remember, if we if we go ahead and put everything on one side, x minus 3, 1 over x plus 2, and then move this over to the left side, minus 2x over x squared plus x minus 2, that should be greater than 0, right? So we don't want to lose sight of the fact that, you know what, we can put this into y1, and then we're just checking to see when is y1 greater than 0. So let's just do that and confirm that we have the correct answer here. So let's see. Get rid of this one. So we have 1 over x minus 3 plus 1 over x plus 2, and then what do we have here? X squared plus x minus 2 minus 2x over x squared plus x minus 2. Put all that in parentheses. Let's just double check if I copied that correctly. Yes, I did. So now, if I go ahead and I graph this, big mess, right? But ultimately, what do we care about? We care about when it's positive and when it's negative. I don't know about you, but I'm having a little bit of trouble seeing right through here. So I'm going to not look at quite so many y values. I think let's look from negative 3 to 3 in our y values. So change our y min to negative 3, our y max to 3. Okay, yeah, that's still pretty tough to see. But we'll make the best of it and maybe adjust our window in a second if we need to. So what was our answer, right? Our answer was, on this page, we wanted to go negative infinity to negative 2, then negative 1/3 to 1, and then 3 to infinity. Those are the intervals where we are greater than 0. So let's see how we did. So negative infinity to negative 2, we're looking positive, right? There's negative 2. And then from negative 1/3 to 1, we're positive. And then from 3 off to infinity, we're positive. So the graph is confirming for us what it is that we got using this sign chart.